Hello, Physics 151S students, EPH 151S students. Good afternoon to you people. Good day to you people. Mr. Fish here. Let's see if I can just for a few moments just show myself to you again as I did the last time. I don't know if this thing is going to work. Let's just put on this screen and share the video for a few moments with you. Hi there, that's me, and let's just take off my specs if I can just show you. There I am. Okay, I don't want to keep myself there, that is not so important, so let's stop that. Okay, thank you. Put my specs back on and let's get going. Students, we want to now look at part 1 of chapter 1, that is mechanics. We're doing mechanics, chapter 1. There are other chapters in mechanics as well, and besides mechanics, there are other sections of physics that we will be discussing. Okay. Now, I need to see where I am, see if I can see something here. I must open something. Yes, that is there. Again, I'm not sure. If you don't use the thing, then let's see. I think I'm a bit lost here now. Yeah, my screen, everything isn't showing on here now. Here we are. As I added an entire screen, I should show Windows. There are two things shown on here. What I want to look at is this one. Share. Right, this is the one I want to actually show you people, and that is your chapter 1 of mechanics. Right. My thanks to Dr. Govender, our group leader, Mr. Pence, Dr. Mabuda, who did most of the preparation of these notes. I just added a few things to make sure that what I felt was necessary will be included in these notes. Okay. As people, you should remember, I did send you a set of notes on the whole chapter on mechanics. Please go through that as well. Right. But what I'm presenting to you people now is what I personally feel should be used by yourselves when you people are going to study. I added a few things which I felt, as I just mentioned, which I felt are necessary for you people. Right? So we can actually regard what I'm doing here as going through the notes, but also as a tutorial, because I will present you with some examples that you will not find in the other notes. And at the end of this chapter, I also included a few tutorial exercises that you people can work at. You might go through one or two of them in this or in these sessions, but the rest we would like you people to work on. After all, practice makes perfect. For those of you who speak Xhosa, sifunda ukwenza ngokwenza. For those of you who speak Arabic, nata'allamu an na'mala bil amali. All of that means practice makes perfect. Ons leer om te doen deur die daad. So practice makes perfect. So please, people, you must go through examples as far as possible. Okay. As a basic introduction, people, these things are mentioned here, and they say here, the purpose of this physics course is to teach a student the fundamental physics that will be required in your understanding of your engineering concepts. After all, you are electrical engineering students. Right, so we will be going through physics, but remember the important thing is the physics, that is a basic science, and that is going to be used in our engineering. Okay, right. The textbooks, as we mentioned in the course outline, will be the book called Physics for Scientists and Engineers with Modern Physics, the 10th edition. The authors here, as you can see here, the surname, Survey and Jewett. Oh, there's a triple T there, sorry for that. And there's also 9th edition. You people can actually check in the bookshop on campus. That's Shakes, Funshcakes, I think, yeah, sorry, Funshcakes. They do sell the book, and I actually went to look there, and I see that they have the 9th edition. And the important thing about the 9th edition, as you can see this heading here, Physics for Scientists and Engineers with Modern Physics, and then it's also added to it is what they call Technology Update. Right, that one is the one that they actually sell in the bookshop. Okay. I don't know if the 10th edition is available in South Africa yet, although that is the one that we actually expect you people to get, but I haven't seen it in South Africa yet. We do have the normal 10th edition, but not the one with the technology update. Okay, so you make use of the 10th edition if you have it available, or the 9th edition with the technology update. Okay. So as you can see here, we say here, these notes will be divided into the different parts of physics, as it will be mentioned or was mentioned in the course outline or the study guide. There you can see mechanics, the one that we are going to be starting with, waves and vibrations, electricity and magnetism, thermodynamics, light and optics, and modern physics. So quite a few sections that we are going to be dealing with. Right. Okay, so it's quite a bit of work, but these are the important basics that you people do need to know for your appreciation of your engineering. Okay. Right, and as in some cases they say here, only the bare minimum will actually be presented to you. Right, the rest you'll have to go and read through in the textbook. Okay, but what we feel is necessary for you, that will be presented. If you want a better understanding, obviously you must listen to these notes and to these recordings, but also for your own satisfaction and for your own enrichment, it would be worth your while to at least read through the textbook at least once so that you can have a better appreciation. But then the notes that you have here are more important. Right, when you people are going to be studying for the exam, we don't want you to study from the textbook, that is too bulky. Right, okay, right. In these notes, you will also find not too many examples. There are some worked examples in the textbook, so you can look at that. Here and there, we will go through some examples in these notes as well, especially the ones that I prepare, right, beyond what my colleagues have prepared. Okay, and the tutorials, I will give some examples at the end, and sometimes the problems that you people need to work through at the end, we will try to, as far as possible, make use of the examples in the textbook, right, or the problems in the textbook, right. Here and there we will include extras. In this chapter, especially in chapter 1, I will include quite a few extra, right. Okay, right. Okay, don't forget, there will also be laboratory work that we will have to deal with, practicals, and that will also count towards your final mark. Right, there will be a manual that I am going to upload for you, right, at another session. Thank you. Right, so let's get started. We are busy with chapter 1, and as you can see, the units and measurements. I'll repeat it, units and measurements. Okay, so let's see how we can introduce physics. What do they say here? You find this at the beginning of many textbooks on physics. Okay, as we say here, physics is called the science of measurements. As one scientist mentioned, if you cannot measure something, we can speak about a certain phenomenon in nature. If you are able to see it, we say that you observe it. But if you cannot measure that, then that phenomenon doesn't make very much scientific sense. So it is important that whenever we want to discuss a physical phenomenon, we have to find out ways of making measurements about it. So that once you can do that, then you can see, wow, what causes it to increase and decrease. But if you are able to observe it, find a way of measuring it. So the science of measurement is called physics. Okay, so once we can make measurements of certain things, we can make use of these things to, how can I say here, to determine, I couldn't get to the word now, to determine certain basic laws of physics, right? Our understanding of what happens in nature, right? Okay, whatever we can observe in nature, we can now develop laws, but that can only be done once we are able to observe and also be able to measure so that we can see how things change. Okay, and then later on, if you go do further experimentation, and you can possibly then develop these laws and to see how they relate to other physical phenomena as well. Okay, so as an example here, let's take the phenomenon called force. That is a physical quantity. We know nowadays that we can measure it with a measuring instrument, which we can call a spring scale, a force gauge, a dynamometer. You can actually go into Google and you can find other force measurement instruments as well. Okay. For scientific purposes, we normally say that the unit of force is the Newton. Okay, now I want to just get to a certain discussion. We'll talk about this again, these units. We'll talk about it a bit later on again. But for the moment, let's stick to the Newton. N for Newton. When you write down the name of the unit, can you see there? It's a lowercase. And then the unit. In this case, it is a capital N. In honor of Sir Isaac Newton, who did lots of discoveries regarding forces. Remember, force has always been there. It was just given a name by the scientists, but force in itself was there. Okay, so we speak about Newton and Isaac Newton. Remember, he did not make a force. He just discovered how forces interact in certain cases. Okay. So now, for linear motion, that means in a straight line. We know, as you people have discussed at school, right, Newton, or the force, that is defined as mass times acceleration. Right? Newton's second law, we can say, right? I wonder if I can't just do something. Let's add a few things. I want to possibly use a color here. What color can we use for you now? Let's use blue. Okay, so we now can see there we said a force. Here, remember from school you should know that. There, I'm writing with my mouse now, so I have to do it slowly if you people don't mind. Mass multiplied by acceleration, right? So force is defined like by these two quantities, right? Mass and acceleration. Okay, but then if you look at acceleration, is defined in terms of velocity and time, where we say here that acceleration that will be equal to change in velocity over change in time. Okay, so this quantity can be defined in terms of those two. Take this one over here. This one can be defined in terms of those two, velocity and time. And then what do we know about velocity? We know that velocity can be defined as the change in, I'll use letter X. At school, when I was at school, we used S for displacement. But anyway, let's just use X for distance, change in distance over change in time. Right, okay. Distance or length will be that one over there. So length over time will be velocity. So force can be defined in terms of those two, mass and acceleration. Acceleration can be defined in terms of those two, velocity and time. Velocity can be defined in terms of distance and time. Right. Now, what I want to point out to you people here is, right, the other quantities here we can say some of them can be defined in terms of simpler quantities, but then there are some quantities like mass, distance, and time. Mass, time, and distance. You cannot define that in simpler quantities, right? Okay, so because you can't define it in terms of simpler quantities, if you look at this formula, I can say a T, look by this here, T will be equal to delta V over A, right? Yes, but T on its own, there isn't something simpler that you can put together to get time. So time, distance, and mass, they are actually what we call the fundamental quantities. And in what we are dealing now with mechanics, the fundamental quantities of mechanics. These quantities, here we call it the MKS. Why? M for meters, K for kilograms, and S for seconds. Right? These are the fundamental quantities in mechanics. You will find in other courses, in other parts of physics, there are other fundamental quantities. For example, in electricity or in light and whatever. Right? But these are the fundamental quantities that we know for mechanics. We can speak about the others when we get there. Okay. Now, taking things a bit further, or just speaking about the fundamental quantities, we can use the fundamental quantities, or we can write down the units of many other quantities. For example, force, acceleration, and velocity. We can write them in terms of the fundamental quantities. For example, you have here force is measured in newtons, isn't it? But if you remember what you did at school, this is kilograms, and that is meters per second squared. So I can actually say there, watch this here, kilograms times meters per second times second to the minus 2. That's per second squared. Can you see there? M, sorry, I should say K of the MKS, M for distance, and S for time. And that is equal to the Newton. We can write this one in terms of fundamental quantities. There we are. Okay, or fundamental units. Okay, let's continue. They say that, globally, that means in the world, different parts of the world, different countries, people actually end up using different units for measuring. After all, for themselves, they went and did their own observations and so they got their own units. But for science and for us to be able to communicate with people in other parts of the world, the engineers and the scientists have decided to use what we call SI units. The SI means System International, which means it's an internationally accepted internationally accepted system of units. And whenever scientists and engineers are talking about something, they want to communicate with each other, they use SI units. So you might find a distance measured in feet, for example, or in yards, or in inches, or in millimeters, meters, kilometers, miles, light years. Can you believe this? A light year is a measure of distance. That is distance traveled by light in 1 year. Light is limited, right? It takes time to travel. You can find out what the speed of light is. So once you determine that, you can work out how far light travels in 1 year. So that is a measure of distance. Parsecs is another measure of distance, and there are many others, right? But the SI unit, the accepted SI unit for distance is the meter, right? So it is important for us to know that, right? Okay, and we're going to be talking about the importance of SI units just now. Okay, here are some examples just to show you people. Just as a matter of interest, students, in your physics, rather your Mech Ch1 course, you might see a similar table, just mix up, right? Yeah. So if you have a physical quantity, length, here we have what we call the English unit. This can be the English or the customary British or American US units. So length is measured in yards or in feet or in inches. So what do we know? 1 foot is 12 inches. Right? 3 feet is 1 yard. And also 1 yard is so many meters, 0.9144 meters, close to a meter. But you can see a yard is less than a meter. And what do we also know? 1 mile is 1760 yards. We know, for example, 1 kilometer is 1,000 meters. So here 1 mile is 1760 yards. The metric or the MKS system, in the metric system, the unit of length will be the meter. And there we can see 1 meter will be so many inches. The SI unit will be the meter. So you can see there, feet, inches, yards, miles, kilometers, millimeters, centimeters, parsecs, light years, whatever they are. The SI unit is the meter. For mass, look at the English system. They call it a slug. Please, nothing to do with snails now. Eh? The unit of mass, please, is not a pound. It is not a pound, please. A slug is a unit of measurement, right? In English, right? Okay. It will be 1 slug will be so many kilograms as a matter of conversion. Metric system, it will be kilograms, and the SI unit is also kilograms. Time, I'm using the first three first, MKS. Right, so time, seconds, and here you can see it's the same. Remember, time can be given in hours, in minutes, right? But the SI unit is seconds. Try to steer away from minutes and hours, because that is a bit confusing if you want to use that type of thing for conversion purposes. Okay, you can convert from hours to seconds or from minutes to seconds, but for SI unit purposes, it is better to rather make use of the second. Okay. And then force, we say there is a metric system. It is newtons, and the SI unit is also newtons. And here you can see, according to the British system or the American customary system, a pound is actually a unit of force. Okay. That is where we have the misconception sometimes. When people ask you, what is your weight? Then you say it will be so many kilograms, but it's not correct. Because we know nowadays that weight is a force. Right? Weight is a force. So if they say your weight, if you want to say your weight in newtons, you can't go and give your value in kilograms. Right? You have to take your value in kilograms, and remember, what do we say there? Weight, that is equal to, from school you should know this, mg, isn't it? Your mass multiplied by the gravitational acceleration of the Earth. Oh, yeah, okay, if you just take it as a constant. You should know that this value changes at different points on the Earth. Right? We will see if this might be discussed a bit later on. Okay, right. So if you think in terms of weight, your mass must be multiplied by that g, then that is your weight. So for example, if g had been 10 and your mass is 60 kilograms, then 60 times 10, 600. 600 newtons, right? I think the value that you people used at school for G, that would have been equal to 9.1. 9.8, sorry. 9.8. I think here at university we might use a more accurate value, 9.81. And the unit for that is an acceleration, so it will be 9.81 meters per second squared. Okay, a few others there. Temperature, you can measure it in the British system, Fahrenheit. Metric system will be Celsius, but the SI unit is the Kelvin. In thermodynamics, we'll talk about this again. Energy, remember we say here, energy, we think of work done. Work done will be equal to, at least that is weight here, but we also have W for work done. Sorry for that confusion. That is a force multiplied by distance, right? Force multiplied by distance, or force multiplied by displacement, while that force is applied. So that will be newtons, and that will be meters, right? So Newton meter. So energy can be seen as Newton meters, or work done is Newton meters, right? Can you see here? Foot pound. Right? Same thing, same, according to the same definition over there. Right? That will be your foot for length, and that will be pound for force. Right, so it will be a foot pound or a Newton meter. Right, okay. The MKS, well, the metric system will be the Newton meter or the joule, and the SI unit will be seen as being the joule. Again, the energy, as you can see, according to this formula, it is a combination, right? So this here is Newton, rather kilogram times meters per second squared, and this here is also meters, right? Okay, you will see view. Okay, that's just newtons, that is meters also, right? So you can just call it a Newton meter squared, but as you can see, if you want to, you can actually go and work out all the basic fundamental units for this, right? You do it as an exercise and see what you get. Okay, we also call it the joule. Okay. And you'll see when we discuss thermodynamics, we might end up talking about other units of energy as well. Okay, just a few examples there for you people. And what is important about this? They say there's some common units, right? These are what we call the common units sometimes, right? In different countries, they have different common units. Then you have the metric system and the SI system, right? Sometimes they are being used in textbooks, these common values. And if you want to use values in the calculation, normally it has to be in SI units. And for you to be able to do that, to use those things that you have measured in common units, then you will first have to convert it to the SI unit before you can use it in a calculation. Okay, please keep that in mind. But if you have to do this, you must know what the conversion factor is. Say, for example, yeah, let's take this thing as an example. If I want to ask you to determine the amount of meters in 1 mile, a person moved for 1 mile, and you want to work out a calculation involving that distance, then it must be in meters. So you must first convert the mile to meters. So from this table over here, you can see here that 1 yard will be so many meters, and so many yards you find in 1 mile. So if you know 1 mile, how many meters are in 1 mile, firstly you know so many yards, and then you can convert from yards to meters. So that's what we've done. Let's see there, 1 mile is 1760 yards, and 1 yard is so many meters. So all that we do now is 1 mile is so many yards is equal to that multiplied by that, and that will give me my answer in meters. And there's the answer. I didn't round anything off. I thought I'll just give everything to you people here. And I think common terms, we normally round this thing off a bit to give you a better value. Right, anyway. Okay, here, just for enrichment, please read through this section in your textbook. That's in the 10th edition. I don't know if it is the same number in your 9th edition. It speaks about how scientists develop their laws, their models, and all those things, how they end up getting an equation. But you need you people to know this for the exam, but it is worth your while to understand this. But also read through it as a scientist. Okay. I just want to just go through these things before I'm going to end off this session. Okay, remember, length is a distance between 2 points in space, either in a straight line or along a curved path. But the length, the distance between two paths, that will be called length. Okay. So there are different ways, okay, different units rather that you can use to measure distance or length. Right? Okay, so there we are some examples in the metric system. We will have millimeters, centimeters, meters, kilometers, etc. In the British system or the US customary system, we said there that they are using inches, feet, yards, and miles. But for physics, remember we said we want to use SI units, so it must be in meters. Okay, in the lab, sometimes you people, or sometimes when you are dealing with measurements, sometimes you use it in other units, for example, millimeters or centimeters. But for you to use it in a calculation, you must still get it into SI units before you can use it in your particular calculation. So you have to be able to convert like this also to your SI unit. Then in mass, the SI unit is kilograms, but remember we can get grams, milligrams, you can get slugs, as I said earlier on, and whatever. But for you to use it in SI units, make sure that you convert them to kilograms. And time, the SI unit is seconds. So if you want to find out what happens in 1 week, then you must know that 1 week, let's say call it 1 week, that is equal to 7 days in terms of time. So I'll just use a D, and that will be equal to 7 times 24 hours in 1 day. But we don't have seconds yet, isn't it? So that will be equal to 7 times 24 times what? In an hour, you have so many minutes, times 60. Now we have that 1 week converted into minutes. So remember, that's 1 week, that's so many days, and that will be so many hours that will be so many minutes, and then that would be equal to 7 times 24 times 60, that is in minutes. Convert that to seconds, times another 60. Then you have all your time of 1 week converted to seconds. Please work it out and see what you get. There, there, and there. You work it out and see what you get. Okay, as a matter of interest. Sometimes if you remember these things, then you can quickly, well, you don't have to go through this whole process every time. Okay, I'm going to stop here, and then we can continue with a further discussion in the next session. Thank you.